Hi, everyone. Good afternoon. Today, my topic is data processing on a decentralized platform. Sound check is okay? Okay, cool. All right, first, a little introduction of myself. My name is Raymond Fu. I'm a big data architect. So for over 20 years, I've been doing data warehousing, business intelligence, implementing big data platform solutions. And it's in recent years that I started to look into blockchain. And I always want to see how we can connect data and blockchain. With this booming business with blockchain, I want to get my piece of pie, just like everybody else, right? So I'm also a blockchain consultant for a university, a Chinese university, Hunan University FinTech Research Center. So before we talk about decentralized data storage, let's talk about data storage 101, how data can be stored. Well, the first one is very easy. We have file system. Once upon a time, data and file are the same thing. You have the piece of data, you save them as a file. So that's the very basic form. And then we have relational database. A relational database is data in a tabular format, and you have indexes. And with the indexes, you can actually create relations between the data, making the data easy to query using a language called SQL. So that's the next generation of data. And of course, we have reached the limit of the data we can process in the relational database. And that is why now we have something called NoSQL database. With the name, it's not something you can easily query with SQL. But of course, we have implemented SQL-like language to process those data. And the data, most of the data are in the format of a key-value pair. So basically, your data is your value. And then for every piece of data, you have a key. That key is used to find the data in the platform. And there are three kinds of key value pairs, three kinds of NoSQL databases, and basically they're just different formats of key value pairs. For example, the document store, you can think the whole document as the value, and it's got a key. With the key, you can do a search. So that's data stored on a single system. What about multiple systems? Today, we have implemented distributed file systems where you can have not just one server, but a cluster of servers where you can use to store your file. And all the file systems on all the servers are just like a whole cluster you can use as one machine. And we are able to do that. And of course, we have NoSQL database implemented on these distributed systems. So it's already out there. For example, Hadoop. I don't know if you guys heard of that. That is a cluster of servers used as one machine, and it can store a lot of data, and then you can process that as quickly as if they're just one machine. So we already have distributed file system. Is that enough? Is that what we're talking about today? No, because distributed does not equal to decentralized. There's a huge gap between these two, even though they're all multiple servers using as one. So what are the differences between decentralized and distributed? Let me show you this famous graph here. The first one is centralized, and it's very easy. Every node connects to one, and if that single one in the center is down, then your whole system is down. The second one is decentralized. As you can see, it actually has multiple centers, and from those multiple centers, you have nodes that connect to it, and they're all linked together. And the third one is distributed network. And I don't know if it's just me or you think the same. If you just look at the graph here, distributed looks nicer. It's less dynamic. And if you want a stable system, less dynamic is good. So why is distributed look nicer? Because there's a secret behind it. And that secret is distributed system belongs to one owner. Because it's belonging to the one owner, you are able to manage it better. And for example, Hadoop, the famous distributed file system, it has data node and it's also got a name node. The name node are actually the ones that's managing the whole system. And because they're all belonging to one entity, you are able to create the name nodes to manage all the other nodes. Whereas for decentralized system, all these nodes belongs to different owners. And they might do different things. They might even want to sabotage the system. So that's why for a decentralized system, we need to create rules, or we can call it consensus, to make sure everybody is doing the right thing and then making sure the system is doing what it's supposed to do. So a decentralized platform should do all these things on the right-hand side. It should resist DDoS, distributed denial of service, which means bad guys hit your servers a million times and make it unavailable. In a centralized system, you just attack the server in the middle and your system is down. But in a decentralized system, of course, you have so many different centers. If you take down, unless you take down like more than 51% of the system, everything is still running. And of course, zero downtime. If it's decentralized, your data is replicated, you take down one of them or a few of them, it won't matter. The system will still go on. Same thing, fault tolerant. You need to have all your data or your process replicated on multiple nodes. So if one is down or it's wrong, there's a way for you to fix it. And the last two, censorship resistant and self-sustaining, that involves more about not just the technology, but also the owners behind it. They need to believe in this system, and if there's a censorship from the government or any authority, the technology is supporting you to be able to keep the system going on. For example, blockchain has been out there for many, many, many years. There are authorities to say, okay, they want to shut it down, but you can't. Same thing goes to self-sustaining. There's got to be a mechanism for the people to actually keep this whole system going. And that mechanism I'm going to talk about a little later. All right. So why do we need decentralized data storage? Why do I have this talk today? It's because different entities, they want to share data. They want to share information. Let me give you an example. Today, a patient will have its information with the hospital, the insurance company, and your doctor. And today, these three entities, they don't share data. Why? Two reasons. One, they don't trust each other. They don't want their data to be compromised. Number two, when they share the data, you use that data, you apply machine learning, you create this AI doctor that can solve a lot of problems and diseases, and you're not going to share the profit with the data owners, right? So that is the problem we're having today, and that is something I believe the decentralized data storage can solve. So what's building the trust and the reward? Blockchain is doing that, right? But we can't use blockchain for data storage. Why? Because blockchain data is stored on every single node that supports that chain. And that's a lot of data that's being replicated. And if you put everything on the chain, that means all the data will be on all these servers. And it's a waste. So we should not put everything in blockchain. So what can we use blockchain for? And there are the three things that blockchain is bringing to the table. Number one is trust. Because the data is encrypted and securely stored in a secure system, you can build the trust between these entities. And reward mechanism, that is the mechanism I talked about just now to keep everything going is, you're making something, you're making money. The blockchain technology actually approves the greediness of a human being. So we're allowed to make money by doing something. And of course, since you have this mechanism, you have this system, you can do a lot of things. You can share responsibility. So if there is a chain among the hospital, the doctors, and the insurance company, they actually can cooperate and then make this AI doctor a shared value among them, and of course they will share the responsibility to build this AI doctor, and then whatever this doctor makes, the profit will be shared among all the entities. So that is why we need a decentralized data storage. So we talked about the what, and we talked about the why. Next, let's talk about the how. How can we implement a decentralized data storage? I think I missed one slide here, but that's okay. I want to tell you the three different approaches for you to build a decentralized system. We can build decentralized system from, we can basically, the one approach is we can build something brand new. We can build the data storage and use blockchain technology to implement the trust, the reward mechanism. And that's what Filecoin is doing. Filecoin is actually a company local here, and they are trying to build this brand new data storage implementing blockchain technology. That's from data to blockchain. And then another approach is from blockchain to data. And that's what Ethereum is doing. We all know Ethereum, right? And when Vitalik Buterin was creating Ethereum, he actually has a bigger plan. He wants to create a supercomputer. Now, for computing, there are three different things for computers: compute, storage, and network. And Swarm is the project to tackle the storage problem. So that's from blockchain to data storage. Is there a third way? We all know, computers are made to do different things. Not all computers are created equal. We could have computers that's good at storage, and we could have computers that's good at processing, right? So I think if we want to build a more complicated or sophisticated system that supports different needs, we should have a structure that will tackle storage and computing separately. And that's the third approach I'm going to talk about, the MOAC IPFS subchain. They will implement a storage chain as a subchain. So that's the three approaches and the three solutions. And I'm going to go over all these solutions one by one. Before I dive into the solutions, I want to talk about something that's called IPFS, because this is something that all three solutions are using. What is IPFS? It's a protocol. What is a protocol? It's a technical agreement for people to implement technology. So basically, in today's world, one company alone is not going to build something that everybody uses. So all the companies are building different components, and they need to be able to put these components together. And the rule that they need to follow is a protocol. So IPFS is a protocol. HTTP is another protocol, a very, very famous protocol. And with HTTP, we build internet. IPFS is a protocol that is used to build the next generation internet. So what's in IPFS? It's very, there's a lot covered in IPFS, but the very basic one is the files are identified by their hashes. So today, when you need to access a file, even whether it's on your machine or it's on internet, you will have to know the domain name, the folder name, and then your file name. With IPFS protocol, you don't access your file this way. You access your file by hashes. That way, it's independent of any servers you're using, whether you're using Apple or using Ubuntu or using Windows. You can always use this hash to get to your file. So how can you access a file with a hash? Let's take a look at this diagram on the right-hand side. It's a little technical, so let's bear with me here. The files that you are putting into IPFS are cut into small blocks. So L1, L2, L3, and 4 are your data blocks. And every data block is hashed into a hash key. And every two hashes will be added together and hashed again, create another hash, and two of them will be hashed again until you get a root hash. And the root hash will tell you where your file is. If you know how a blockchain data is stored in blockchain, actually this is how data is stored in blockchain. It's called a Merkle tree. So all your data is in blocks, and then they're hashed by pairs until you get the root hash. And the root hash is put on your block header. Why we do it this way? Two reasons. One, with this hash, you will be able to identify your file, and you know that's your file. And the second thing is, we all know that by doing a hash, if you change maybe just one comma in your data, then the hash will be different. And if the hash on 0, 0 is different, then it'll change hash 0, and then it'll change your top hash. So basically, with the root hash or the top hash, you will know if the file is exactly the one that you're looking for. Because if it's not, then the hash will be different. So that is a very tricky, a great design that is used in blockchain, in GitHub, and also in IPFS. So you can think about in the future, when you are accessing files in internet, you don't have to use domain names. You don't have to use folder structure. You just use the hash. But IPFS is just a protocol. With IPFS alone, you are not able to create a distributed file system. So what else do you need? Well, you need a storage provider, right? You have the protocol, but you need the participant. You need people to share their storage, their hard drives for you to store the files. And then it can't be just random people putting their hard drives on the internet, right? You need guaranteed storage system, guaranteed storage service. And by guaranteed, it means, first of all, you need to have enough storage space. You can't have a system where you can store more than 2 terabytes of data. That will be useless. And also, they need to be reliable. So I can tell you that IPFS is actually an open source project today, and there are IPFS network that exists today. But everybody just participate, I guess, for research purpose or for fun. It's your work is not guaranteed to be stored there. You store something there, it's guaranteed to store on your own machine, but when you can't guarantee it's stored somewhere else. So we need to have reliable storage nodes if we want to build this decentralized storage system. And the third thing is fault tolerant. Of course, your file is stored on some of these servers, and you want to make sure your data is still there when that server goes down, right? So the whole mechanism should be able to replicate the data that you store on that server when it's becoming unavailable. And in order to do all these, you need rewards. Again, the greediness. You need to reward people's greediness, then they can do the stuff. All right, so let's move on to our first. Actually, any questions so far? Because we can be more interactive with a small team here. Go ahead.
About that hashing tree. I would understand that if you have the whole data, you can confirm that it's the data you're looking for from the hash. But I don't see the other way. Did you say that you can find the file from the hash?
No, yeah, that's okay. I think that's where I know where the confusion is. So there's something that I didn't talk about. It's a DHT, distributed hash table. In order for you to have a million nodes to share all the information, you need some index. So that DHT, that hash table, is where you'll find your file. So you're not using your hash root to find your file. You are actually using that hash table. Does that make sense?
Using that root hash as a key, you go up with those multiple address of those blocks.
Yes.
From the table.
Yes.
I see. Okay.
Yeah, and the good thing of cutting them into small pieces is because you can actually store L1 in 3 servers here, L2 in 4 servers there. And then with that hash table, you should be able to find all the blocks and then get the complete file. And whenever you're getting the files, if the hash is different, that means that server doesn't have it. Yeah, it's compromised. That's correct. Right. All right. Yeah, you're right. There's a verification process going on. Every time you retrieve the file, you need to do the hash again and see if they match. If they match, it's the same file. Thank you. You're welcome. All right, so let's talk about Filecoin. Filecoin is from a company called Protocol Lab. They're actually right here in San Francisco. They are the company that builds IPFS. So they've been working on this project for a long time. They open source IPFS. They're trying to build something on IPFS, but couldn't do it for years. And last year, they finally decided to do an ICO. And it was a successful one. It's actually the biggest ICO in history. $257 million they raised. And using that money, hopefully they can build something really good. Because we all know IPFS is a protocol, and now you need the real stuff for people to use it to store the data and to build the next generation internet. So what do they have to do? Number one, they have to build this network. So there's a lot more protocol. They actually use 3 different protocols on top of IPFS, and then they need to all the file replicating, all the file sharing. They need to implement that. That's the DSN, Distributed Storage Network. Second, they need to build verifiable markets. What is markets? It's for storage and for retrieval. Why do you need this market? Because you need people to use your system, and you need to pay for the service providers. So, somebody's paying the money, somebody is taking the money and provide services. Why do you need market? Let's talk about Amazon first. Today, when you use Amazon, you store your file in Amazon. How do you pay? Amazon tells you, okay, every month you give me this money. I'll let you store your stuff here, right? So Amazon is actually giving you the price. That is a centralized authority that's determined on the pricing. But for decentralized system, we shouldn't have a authority to tell you how much you should pay, and how much you should pay to store your file, or how much you should earn by storing the file, right? So that is why Filecoin is creating a market for the client and the storage providers to bid on the task. So if you have files to store, you can make your own price, and then of course their storage providers bid on the file, and the one who's the lowest bid will get to work. That way you can create a dynamic way of pricing that is completely decentralized, which is very important for Filecoin. I think this is a concept that they implemented, and I don't think anybody else is doing this, and I think this is great because this is truly decentralized. And why they need 2 different markets for storage and for your retrieval? Because that's how you use your file. When you save the file into when you save file into Filecoin, you need to if it's a terabyte or a gigabyte, it should be the costing should be differently, right? And when you read the file, if you read the file 1 million times a year, or you read the file 3 times a year, of course the pricing will be different. So that is why you need 2 markets for storage and for retrieval. So that's the second thing that Filecoin is doing. The third thing is verifiable storage. When a file is saved into these decentralized servers, you need to think that you can't trust them all, right? You need to have a mechanism to prove that they're doing what they're supposed to do. So proof of replication means you need to verify that they do replicate the file and store it in their local server. That is something you need to do. And you can't just do it once. You have to do it multiple times. Why? Because if you just do it once, they can copy the file over, give you the proof, and then delete it, right? So that is something you need to keep doing. So that is the 2 proof we're talking about here. First, you need to prove that the file is replicated. Second, file is replicated over a space and time. So and all these proof will be stored in a blockchain. So that is what the blockchain why the blockchain is needed for a file storage system. And last but not least, you need to have a consensus for your blockchain. And I think right now they're using POW, proof of work. As we all know, it's very energy inefficient. And I believe Filecoin is trying to figure out a better way to do it. But I think so far POW is the only verifiable, the only proved method for consensus. So that's what they're going with. Yeah. Okay. So this is a nice diagram to show you what Filecoin is doing. In the middle here, that's the blockchain. These are the blocks. So that is the block you need to maintain by POW. And then on the top and the bottom, these are the two markets that is used for storage and for retrieval. And the computer with the C is the client who has the files that needs to be stored. And that hard drive thing is the miner. So miner in the sense of Filecoin are the storage providers. So as you can see, there's ordering processing and order matching in both markets. And those transactions will actually go to the blockchain. And once a deal was made, then the payment system will go up. But the payment is not going to the storage system at once. It's actually breaking down into small pieces. So basically, every block you will pay a fraction of what the cost is to the storage providers. And we do the same thing on the storage side and also on the retrieval side. Any questions so far?
Sorry, what is the mining part there?
Which one?
Like it says there's mining.
The mining. Oh, okay. So in blockchain, mining means POW, right? You're doing this math problem to figure out who's the next one to store the block, right? But for mining, for Filecoin is actually storing the files. So if you store files, you get paid. So that is mining in Filecoin. All right, so that's Filecoin, the next generation internet. I hope they succeed. Next, we move on to Swarm. Swarm is a project that was sponsored by the Ethereum Foundation. So that they tackle the storage solution for Ethereum. As we all know, every Ethereum node has a virtual machine that's within the node. And the virtual machine will actually do the processing of the smart contract. Now, what they want to do is they want to add a storage to that virtual machine. So basically, that node will have a virtual machine to process contract and another storage mechanism to store data. So this is what they're doing in a nutshell. First, they need to have a separated daemon installed on Ethereum nodes. I don't know if you guys have ever played with Ethereum. There's a tool called GETH. I don't know how to pronounce it, but that is the tool that you can use on your nodes to participate in Ethereum. So basically, for Swarm, you will have another daemon that is separated, but it's installed on the same node. And since it's part of the Ethereum, Swarm actually relies on Ethereum for a lot of things, networking. So the communication between these nodes goes through the Ethereum communication method. And of course, they have another project called Whisper that is going to take care of networking in the future. But at this point, it's all Ethereum. And domain name solutions. So today, we have a domain name to access Ethereum. The same domain name will be used for Swarm to get your files. So basically, you have the domain name and then / the hash to get your files. Service payment. Because it's part of Ethereum, you get paid by the same way you paid by paid gas by executing those contracts. And content availability insurance. I'm not 100% sure what they mean, but my understanding is because Ethereum is an established blockchain, you have all these nodes, so your content, it's ensured that your content is available on these nodes versus a small chain that just started with hundreds of nodes, right? And another way to think of the insurance is, Ethereum is going to becoming a POS blockchain. So they're changing the mining from, they're basically changing the proof of work into proof of stake. What is proof of stake? For every node that's making a decision, you have to put some money in the reserve. So if you have money in the reserve for each node, the node, if you do anything bad, you get penalized and you have to pay. So since Ethereum is going towards the direction of POS, I'm pretty sure they can add that into Swarm. So if you claim that you have some file and you're not able to deliver, then you get penalized. So the main purpose of Swarm is to do two things. One, they want to store Ethereum's public record. So all the code, all the documentation, Ethereum wants to be this super computer that has everything in its own ecosystem. So they will do that, store its own stuff. And a second is they want all the DApp code to use Swarm as to store their blockchain data. So today, all the DApps, they have all the transactions on the chain, but all the other information, like user information, other information, it's all on the centralized location that's belonging to the DApp developers. So eventually, we want to decentralize the storage for that. So that's what Swarm is targeting of doing. So this diagram shows you exactly what Swarm is doing. The blue boxes in the middle is the blockchain, the Ethereum blockchain. And the three circles on the side are the Ethereum nodes. And within the nodes, you have the EVM that is used to process the contract. And you have Swarm, which is the data storage. And they have Whisper, that will be their future messaging mechanism that will take care of the network. So computing, storage, and network, that is the supercomputer that Ethereum is going to become. Now, we all know that computers, not all computers created equal, right? So we should have, in order to be more efficient, we should have computers that can do storage, or some computers to do communication, and some computers that does processing, right? We don't have to make all these computers the same to create the supercomputer. We can have one set of computers that are good at doing one thing, and another side of computers that are good at doing something else. That way, we can also create a supercomputer, but it can do a lot more complicated work. And actually, that is the concept behind MOAC. MOAC, M-O-A-C, is a blockchain that has a sub-chain architecture where you can have multiple chains, and every chain will be dedicated to do something that's different. This is also a company that's in the Bay Area. Their headquarters is Palo Alto, and they started. I think they had a very successful ICO last year in June, and right now I think they just released their testing network last month. So what I want to talk about is how to implement an IPFS chain that is used for storage on one of the MOAC subchain. So in order to do that, first I need to walk you over the subchain architecture of MOAC. Lots of information on this one. I'll try to be slow, and feel free to ask me questions whenever. So on the bottom here, in blue, we have the P2P network, which is the same for all different blockchains. You need to use a P2P network to communicate with each other. And then the arrow, you can consider that as a blockchain. And then all the nodes, the blue nodes, are the main nodes. Those are the nodes for you can say for the main chain or for the mother chain. And these are called D nodes. They're doing the POW work. And they are making sure the whole blockchain is stable. Now everything in blue looks very similar to Ethereum. The only difference is that for MOAC, it's recommended to only run transactions on the main chain. Why do I say recommended? Because you can still run contracts on the main chain, but you will have to pay more. So the payment structure is changed, so you don't run the contracts on the main chain. So now we all know the Ethereum was great, but there's a huge problem with the Ethereum is it's too slow. If you run contracts, it could take the system down. For example, the famous CryptoKitties. That game actually is taking the system down multiple times because it's taking a long time to run those contracts. If you take the contracts out of the main chain, it'll be fast, right? That's very easy to understand. So MOAC can actually run like thousands of transactions per second. How many transactions can Ethereum run? 25. So that's a huge boost. But that's not the secret sauce of MOAC, because you still have to take care of the contracts. So who's going to take care of the contracts? The subchains. So this whole structure is to support a way to run only balance transfer transactions on the main chain and then run all the contracts on the subchain. You can have multiple contracts running on the same chain, or you can basically create a subchain for every contract. However you want to do it, this whole system is supporting it. So how was the subchains created? Now, the main chain and the subchain have slightly different nodes. The main chain nodes, the V nodes, needs to do POW. That means you need fast computers, GPUs, ASIC, to run the mining. But for the subchain, they don't have to do that. So that means you can have the commodity computer to do it, or you can even use your cell phone as long as you keep it 24/7 online. So that is the secret sauce behind MOAC is for the main chain you are able to do mining and make some money, but on the subchain you don't have to do mining, but you get paid by executing contracts because you get gas, right? And in order to make sure these subchains are secure, these subchains, the green ones, they don't talk to each other. How do they talk to each other? It goes through the main chain. That is why there's an arrow from every green dot to the blue dot, because you have to talk to another nodes on the same chain through the main chain. So that is very important because on the main chain you could have tens of thousands of nodes, and in order to tackle this whole network, you have to tackle basically 5,000 nodes. That's near impossible, right? But on the subchain, you could have, say, just 100 nodes. And if you want to tackle 100 nodes, you only tackle 51. And it's more possible, basically. So that is why if we don't let the subchains talk directly to each other, then they'll be more secure because you don't know where your peers are. And it's hard for you to find a target. So, and of course, this is basically a architecture that supports that was designed for dApps. We all know that blockchain has three phases now. Blockchain 1.0, which is Bitcoin, took care of balance transfer. And blockchain 2.0 is Ethereum. It's doing smart contract. And MOAC is considered the blockchain 3.0, where it's designed for a fast processing contract that supports dApps. Basically, it's a blockchain for dApps. And it's supporting all kinds of dApps because every subchain can be different. And as you can see, I listed here one of the POS chain, one of a DPoS chain. So because the consensus can be different on the subchain, you can actually use the same chain to support a public chain or private chain or confederate chain. So I listed out all the features of MOAC in red here. Number one is sharding. What is sharding? Say we have tens of thousands of nodes for Ethereum. They all have to do the same thing whenever you execute a contract. What if we can break them down into smaller pieces? Say if we have 10 different groups of nodes of 1,000 each, then you can actually run 10 processes at the same time. So that's 10 times more. So that is sharding, and in MOAC, it's implemented. And multi-layer, what does multi-layer mean? So if you created shards among the blockchains, you're able to do 10 different things at the same time. But they are the same type of things. You can't do different things. But with the multi-layer, you can actually do 10 different things because every subchain is different. Swappable consensus. I already said, every chain can have a different consensus, so you can use for different things. Fast transactions, because you have all these subchains, everything will run a lot faster and smoother. Asynchronous contract execution. So now you have multiple chains to run the contracts. The contracts can be executed at the same time, and they don't have to wait for the other one to complete. So basically, asynchronized means you don't have to wait for one to stop and to start another one. They can start now, another one start, another one start. All right. Questions? Go ahead.
I'm still not understanding what those circles are standing for? The blockchain has, as far as I understand, has two aspects. One is that data structure, those blocks chained, and another is that distributed computing resources. That's totally orthogonal, right?
Right.
All of the nodes share those whole chain.
Yes.
And which are
Well,
diagram?
yeah, those nodes, don't think they're as blocks. I would use like square for blocks.
Okay.
These are nodes. So this arrow here is the chain. So this chain is running on all the nodes. The main chain is blue, so the main blocks is running on those blue nodes. And subchain is green. And the subchain is another block chain that's running on those green nodes.
So the typical, maybe say traditional, blockchains share the whole data.
Yes.
But in this model, they don't. Is that correct?
That is correct.
The main chain is shared by the whole every node. Is that correct? Even the
No,
green
it's
ones?
yes and no. So the main chain has its main chain data, but the subchain has the subchain data. The subchain data is not everything from the subchain is stored on the main chain. And you know why? Because for DApps, if I'm just doing the CryptoKitty, I don't care about the other DApps that's doing something else, right? I only care about my data. So every subchain is dedicated to one DApps or multiple DApps. So they don't have to share information with other subchain. However, there's a concept that I haven't talked about is the subchain will flush periodically its information to the main chain. So not all the transactions from the subchain is going to the main chain, but the status will be flushed periodically. That way we can keep the status of all the subchains in sync with the mother chain. So every transaction on the small chain, on the subchains, the transactions is on the blockchain on the subchain, and then the status will be flushed, say every 20 minutes to the main chain, or that hasn't been determined. So, but periodically we will do that.
And by meaning flush, the subchain's data itself won't disappear, right?
No, it won't. It won't.
And in the main chain, it's the whole data in the subchain would be copied there, or only the hash, or the
only the status, not the transactions, because we all know. Just think of Ethereum, because Mawak is very similar to Ethereum. For Ethereum, you have transactions, you have status, and you have balances. These three things on the blockchain. So for these three things are all stored in the blockchain, but the only difference is the transactions from the subchain does not go to the mother chain. Only the status and the balance.
I see.
Yep. All right, so with the structure in mind, we can talk about the IPFS subchain. So I'm a data architect, so this is my area, and I'm actually working with Mawak to implement the IPFS on one of their subchains. So this is where our work starts. In order for the subchain nodes, the SCS, to do what we're doing, we need to first register those nodes on the main chain. And before you register, there are two prerequisites. Number one, you need to have an extra daemon to be installed, extra components. That includes an IPFS daemon. With that IPFS daemon, you're able to create the IPFS network. And number two, you need to have storage attached to it. You can't just, cell phone is definitely not good for this subchain here. So all the qualified candidates will be registered and put into the pool. And then whenever somebody needs to use the subchain for storage, then these guys in the pool will be called upon. There's a method to pull in just enough nodes out of them and create that subchain. And once the subchain is created, the files are stored into the subchain, and it's replicated. And all the files will be verified periodically to make sure they're all the same. And I actually listed it out here, what's happening on the back end here. Files are copied and distributed among all the storage nodes. file are replicated based on user's choice. You can actually tell the subchain how many copies of the file you want to store. The existence and availability of all the files are constantly verified, and that information goes to the blockchain. And every time we flush, the storage gets paid. Bad or missing files, nodes are found and replaced. So during the verification process, if you figure out a file is corrupted or if nodes is disconnected, we need to be able to replicate it and making sure the data is whatever is there needs to be copied over. And then last but not least, files are encrypted, so the storage nodes cannot access the content of the file. Of course, you're storing your data on somebody else's computer. You don't want them to see it. So that needs to be taken care of. So when I applied for when I proposed for this speech for this conference, my original topic is big data processing on decentralized platform. But I feel like we're on the very early days. Blockchain is still new. I think we have a lot of things to take care of before, right? So we want to take care of data in general first. But that doesn't stop me from showing you this, which is a vision on how we should process big data on a decentralized network. So this is a vision, and I think it fits the subchain architecture of a Mohawk very well, because for Mohawk, the architectures is you can have multiple chains, and each chain is used to do different things. So this example here, we have a DApp that's executing some contracts on one of the Mohawk subchains, which is the POS chain, right? So you can run your transactions. Say it's a game, then all the game information transaction information goes to the POS chain. Now, for gaming, the user activity is very important. You want to know how the gamers is interacting with this game, and then you can create something that's more smart, right? So you need to collect all the user behavior information somewhere, and that piece of information can go to the IPFS chain, where the data is stored in IPFS. And once you collect the data, you know that you can apply machine learning to train the data and then create models and figure out the patterns of the data, and then you can create models that you can execute to make your system smarter. So that is the artificial intelligence I was talking about. By analyzing your gamer's activity, you can probably create a super user that can just behave like a human being. So this is the big vision of how we can implement big data processing on the Mohawk chain, subchain. Questions so far? All right, so this is, I talked about all the good things, and just one last slide about the challenges. We still have a long way to go. Number one is popularity. You need to be able to, once you have a distributed file system, you need users to use. It's not like you can just build it, because you have to pay for the service provider too. So popularity is a big challenge for all kinds of distributed storage system projects. Security, we can't enforce enough on security, right? Your file is stored on all these nodes. You want to make sure once it's compromised, your data is still safe. Performance, this is something we will have to try in the long run to make sure all these mediocre computers can be able to support the performance needed for a distributed storage system. Features and functionalities. Once we get there, today you use AWS, Amazon, there's a lot of features and a lot of tools that you can use. And all these tools and features are not existent, right? So that is something we will have to do. And last but not least, compatibility. You need to be able to, say Filecoin is creating their thing and Mohawk is creating their thing. Are they compatible to each other? So these are the challenges that we are facing. All right, I think I'm almost right on time. I don't have, maybe we don't have time for questions, but yeah, just talk to me, and I'll be here. I'll be around. And thanks for listening.